all about Seymour Papert. I really hope tonight we get really going to dig deep, and I know that our presenters are going to get our hands dirty. It's not just going to be a lot of talking at us. We're going to really find out what Seymour Papert meant when he talked about Constructionism. He wanted us to really experience it, right? So it's more going deep as opposed to maybe trying to get Seymour Papert to compete against other kinds of philosophies. We really want to understand what's going on here tonight. All right, so with no further ado, I'd like to introduce Tracy, Kelly, and Michael, who are going to lead us tonight in our exploration of Seymour Papert and his project-based learning tools.
Hi, I'm Kelly Turkle. I am a middle school computer science teacher, and I run a Seymour Papert book club. We meet on Google+. You can actually come join that group. I don't know when the next meeting actually is. Thank you, Karen. Tracy.
Hi, I'm Tracy Macias, and I teach in middle school, computer and related things. And I've been a big fan of Seymour Papert and the way that he approaches and the way that his ideas about how kids learn for a long time. So.
Michael Temple, I'm head of the Logo Foundation, and I've been working with education technology for a very long time. I'm working with Seymour Papert for about 35 years.
So before getting deep into Seymour, we just wanted to give a little bit of context of who this man is. And this is my kind of ridiculous scratch project. Keep in the back of your mind that he was born in South Africa. He actually ended up first being focused on mathematics. And he has his PhD both in South Africa and also at the University of Cambridge. Now, the big changing point is actually when he started to work with Jean Piaget. He actually influenced Piaget's concept of how kids learn about math, which, like most people in the education sphere, know who Jean Piaget is. I want more people to actually know who the awesome Seymour Papert is. You skipped something, but that's all right.
Huh?
I know. Yeah. So in our that's all right. In our please don't look behind the screen. This is quickly coded. Oh, awesome. So he, after working with Piaget, he ended up actually, so many devices. Yes. He ended up actually going to MIT in the 1960s. And from there, we have the awesome implementation of Logo. And the research with Logo, I actually will admit that when I was a child, I actually learned Logo in my computer lab at my school, and it was amazing. So I actually, when I became a computer science teacher, I was always searching out for that turtle. And also it being this piece about moving your body and thinking about it as you are actually the turtle and moving around through space. For me, it was such a amazing, radical way about thinking about the spatial awareness and everything like that. So now, Seymour's actually published a lot of different articles and what have you. His first book in 1980, Mindstorms. And it's about the powerful ideas, the things that he was actually noticing in his research with MIT while they were in schools, but not a part of schools. The one thing to note is that this book actually wasn't written for educators in mind. Educators actually started writing him. Retweeting him. Yeah. They started writing him because they were actually so curious about how this could apply to what they were going on in schools. And next, we have a lot of the different projects that he worked on. I'm not even going to talk about all of these. One of my favorite, and this is somebody, please shout out to Gary Steger. Yeah. Thanks. Oops. He actually worked. That's all right. One of his projects was actually working for juveniles in a juvenile detention center and making some amazing things. Ask Gary about it. Then he has connected.
real quick through
That's all right.
cute little thing here.
All
There
my
we
super
go.
cuteness. Okay. Children's Machine. Currently, I am running a book club on Children's Machine. Join it. Stalk me on Twitter. It is amazing. Children's Machine was actually written for educators. So this is actually your piece where, as an educator, this is Seymour thinking about educators and some fantastic analogies. And it's a great text to actually look at through the lens of some of the stuff. It was published in '93. How much it's still relevant to today, and it doesn't even need the dust to be blown off. It is so completely relevant to right now.
Okay.
Next. And then last book published is Connected Family, so Mindstorms was just out of research, Children's Machines educators, Connected Family for audience of parents. And that is our lovely backgrounds.
Okay. Do you want to do this one now?
Yeah, let's do that.
Before we get to that, I
Okay, yes.
added some context here.
Oops. Oh, do you want
Oh,
me
should we
to
do that?
Now, go, no,
You know what? It's
We
not
didn't
even me
practice.
clicking. It's just,
go on
It's being-
background again.
Okay.
okay.
Oh, I think it's your
Get to that
mouse.
list
I'm
of
not good at the, because
school
I'm used to,
Oh,
projects.
you're used to a Mac,
that's
that's
why I
why.
was
Oh,
used
okay.
to.
Oh, which one do you want?
The project list. There's
Okay,
an
I'll get there.
interesting breakpoint. Well, there's several breakpoints. If you look at that biography.
Yeah, he's just,
In
yeah,
the early ones,
whatever.
as a
It's cool.
mathematician, and then working with Jean Piaget. And then moving to MIT into this world of AI and computers. But a lot of the work that went on from the late 60s to the 70s was, it was done with kids, it was done in schools, but these were not school projects. It's sort of like, Willie Sutton, the bank robber, when he was arrested for like the third or fourth time, somebody asked him, why do you rob banks? He said, that's where the money is. So, why work in schools? Well, that's where the children are. But there was no connection with the schools. The researchers would come in, do their work with the kids, and then there was also work done with them at MIT. The key break point was around 1980. And it was an interesting coincidence of things that were happening when Mindstorms was published. But everything in Mindstorms is, Seymour's thinking from pre-1980. Obviously, it was published in 1980. And it was all about learning. And there are two. How many of you read the book, Mindstorms? You should, if you haven't. And if you have, here's a perspective, I think, to go back to look at it again. The two, to my mind, the two most important parts are the forward and the last chapter. And the forward is like 3 pages long. It's called The Gears of My Childhood, where he talks about his learning mathematics in relationship to his knowledge of gears. And I won't go into the details, but it's the idea, the personal connection with knowledge. And that a big part of that is connecting something new to something you already know. So he could learn algebra by relating back to gears and multiplication tables. And then also the affective component. This was compelling for him because he loved this stuff. He loved the gears. And so connectedness and affect. And then the last chapter, this is like 176 pages into the book. He says, essentially, by the way, you've noticed that I haven't said anything about school. And then he finally addresses the elephant in the room and says that his vision of a learning environment, and it's not school, it's the Samba schools, which are they're not schools, they're social clubs in Rio, where people prepare for their pageant and carnival. And what he's saying about it is that, first of all, it's intergenerational. The learning is largely informal, with occasional formal instruction as needed. And it's rooted in the culture. And then he goes on to point out how school is not any of that, most formal school. And then he talks about logo culture as being, at that point, very undeveloped, and that's something that we're all going to use. Now, the thing that also happened in 1980 around then, which is interesting, and that's when I first met Seymour Papert in the Computers in Schools project. I was working at the New York Academy of Sciences, and this project was a joint project of MIT, the Academy, New York City Public Schools, Bank Street, Texas Instruments, and Teachers College. And we had a grand total of 15 computers for New York City. 3 of them were at Bank Street, and 12 of them, actually 16, I had them. And 12 of them were distributed among 6 schools, 2 teachers in each school, so that's 1 computer per classroom. So it's a different world. But this was the first time, really, that he was connected to schools in the sense that these are school projects. It wasn't researchers coming in and working with the kids. It was the teachers. And what we were doing was training the teachers to work with the kids in computers. The first Logo Summer Institute, which we're still running, there's a flyer there, pick it up on the way out, was 1980 at the Academy, and we had these teachers from Bank Street and New York City Public Schools. There was another part of this project in Dallas, the Lamplighter School. The reason for that is that the CEO of Texas Instruments had a granddaughter at the Lamplighter School and decided they should have computers. So this was a school with 450 kids, and they had 50 computers, which was at that time a level of density that was just outrageous. And so for the few years just prior to that, there were these implementations on microcomputers of Logo. There was TI Logo, Texas Instruments, and Apple Logo, earlier versions of this, and we were using those prototypes in the projects. Now, so the whole perspective of shifting from personal learning and thinking of the learning environment that you want to create to working in the real world of schools, I think was quite a shock. And if you look at the difference between Mindstorms and then Children's Machine, where Children's Machine is about school, and Seymour has some not very kind things to say about school, but it's like he idealized school with a capital S. And what he means is kind of like an archetype of what school in its idealized form would be like. Whereas actually the real world of schools is much more complicated. And there's plenty of bright spots, I think, that we can get into. So then there were all these other projects that poured out of this. Some of them lasted for a long time. St. Paul Logo project, this was in Minnesota, went for 18 years, which was really quite something. We were doing, at any given time, about half the schools, public schools in St. Paul were in the project. Teachers working with students with Logo. We did regular professional development all this time. And some others went in and out. Some were the Ardengo Foundation in Costa Rica. We started with them in 1988. A bunch of people from Costa Rica came to MIT. We did workshops with them, and that project, that became pervasive throughout the public schools in Costa Rica. And there have been many, many more. This is really a partial listing. So if you look at Seymour's life work, he starts mathematician for some period, this close work with Piaget, then the research phase at MIT, and then the out into the world of education. So that's a little context there.
Okay, so now we've spoken quite a bit, but we're going to actually give you all a challenge. And it's nice to at least have that contextual framework, because Seymour is not as popular and loved as he really needs to be. So we have a challenge. You need to figure out how to make a program that makes a word plural.
Now we're going to do this together, okay? And this is actually an exercise that goes way back, and let's do it and we'll make it.
But one thing about Papert is that his ideas of things really connect a lot to language. Programming is language, but that when he works with kids and young kids even, that they can understand how to put, he works like in the frame of procedures, how to put these kind of things together and kind of create them, working through ideas like word problems in a sense of using language. So using letters, using language, and trying to figure it out. And then the context for all of his works, obviously in Logo, and Logo was created not as a computer language for the sake of being a computer language as much as being what he felt was a language that had a low kind of entry point for kids. Like even though they had to learn certain kinds of rules with it, that they could kind of focus more on their ideas and like figuring things out and debugging things as opposed to learning the language itself and the rules of the language.
Right. Now, keeping in mind that this is now a very old language. I mean, in context, the presentation we're doing, Kelly wrote that in Scratch, which is like the current version. And there's a whole discussion we can get into about blocks programming versus text programming. But for those of you who are technically minded, Logo is a dialect of Lisp, and what Tracy said about language, the name Logo means word in Greek, and that was chosen because to emphasize that it was language manipulation, not just numeric, which again, you got to put in the context of when this first version of Logo was developed in 1967. And the one that we're going to use here, this is an early 90s version, but the language just goes back, this is like a 30-year-old version, but it's still compelling. So here, I'm going to cut through the syntax if you're not familiar with Logo. You're going to do the logic, and I'm going to hack it out here. So what we want to have is a program. If I say print plural dog, and I say quote dog means take that literally, that's the word, not a procedure named dog. I want it to give me dogs. But right now it says I don't know how to plural because we haven't written it yet. So it says I don't know how to, and the way this works in Logo is you say to.
And Seymour calls this teaching the turtle
Can
new
we drag
words.
the window sideways a little bit because I think we're missing some of the left.
Oh.
Whoa. Yes, we can.
Yes.
Better.
There you go.
Yeah.
Is that it?
Yeah.
So Seymour, he talks about this as teaching the turtle new words. And so the idea is that it can be any word, and that the kids are kind of trying to construct these rules, these ideas, and trying to figure out a way to, so the procedure itself is a new word that we're teaching the turtle, so, because it doesn't know how to plural.
Yeah, and it derives directly from that. It says I don't know how to, you say, well, to, plural. And this is going to have to take an input because you want it to take a word as input and output the return in Logo is output, to output plural. And I'll just abbreviate the variable name as WRD. And the colon is just the syntax of the variable. So what's the logic here? What should this be outputting?
Word plus S.
Okay. Now, the way you make the concatenation is the procedure, built-in procedure called word. And word takes two words as input and outputs the combined word. So the first piece of that is the input word, and the second piece is this. And when you're done with your procedure, you say and. Okay, so now I do print plural dog. Oops, spelling counts. And you notice the error message, it just says I don't know how to. Because if you use a word that it doesn't know how to do that. So it doesn't know that I meant output. All it knows is that it's a word it doesn't recognize. Okay, so now, dogs. It works. Perfect. We're done. No? Okay. So here's what we do now. And the meta point here is instead of being taught the rules of plural we're constructing those rules. You know, normally you say the rules of pluralization are, the exceptions are, and then you come up with examples. So we're going to do it the other way around. We're going to build it through that. Can somebody give me a word that could cause our programs some trouble?
Fish.
Fish. Fish. Okay, so what do? We have to fix this. So what's the rule?
Thinking hats.
Give the rule, just describe the rule, and then we'll code it.
What do we need to do? Just say
Wait,
it in
well,
English.
It ends in an SH, it switches to fishes or dishes or
Okay, so if it ends in SH, then we have to add
Yes.
ES.
But
Okay.
isn't it all H's? It's catch. Oh no, catch. Never mind.
See, that's the thing.
Catch is a noun. Catch is a noun.
Yeah,
catch
you
is a
have to
noun.
kind of like.
Yeah. What we need is just the last two.
Switch. Switches.
If last two of the word is SH, now we're going to do it equal. Last two word SH. Again, for the technically minded, this is prefix. So equals X inputs. It's either true or false. The last two is going to take an input, which is a variable word. And if that's equal to SH, output.
Spelling.
Thank you.
Spelling.
Typing.
That's typing. For me, it's both. Both is,
Typing and stuff.
output a word, make a word, and ES. I won't go through the details of the syntax, but the point of the syntax is it's quite uniform. It's rules like any text language. There aren't a lot of rules. They're all the same. Now, let's see if this will
Do you need an end?
Sorry?
It has an end.
No, end is for the whole procedure.
Yeah. All procedures start with a 2 and then an end.
So let's see if this works. I don't know how to last two. Now I confess I knew that, but I was going to let it happen. See, last two is not a primitive. It's not built in. But no problem. We just define it. And I'll just use the input W. I'm going to start abbreviating. Output can be abbreviated. Okay. This is another important point in the design of language, that there are long forms which say what they are, and short forms when you get tired of looking at my typing notes. You know what I mean. So output a word, there's no abbreviation for word, made of, I'll explain this in a moment.
In my classroom, I have a lot of the, I teach logo, and I have a lot of the stuff.
You teach logo?
Yeah, and I put a lot of the text up on
Yeah.
the walls because I want to impress upon the kids it's not about memorizing the commands necessarily, it's understanding how to use them and where you're using them.
Sorry, it's not over to a small font. Okay, so there are manipulators of words and lists. It's last, which is the last element. It's a word, and it's the last character. But last is everything but the last character. So if I have a word, the word fish, last but last is S, and last is H. So I'm making a word out of those two. So now I have last two. Now I could have put all this code into the main procedure, but by creating a sub-procedure, it compartmentalizes that. We understand how it works. It simplifies the main procedure. Okay, let's see if this works. Okay. Now, we could go on with this. We could spend all night. We could spend all week. The thing is, as you go with this, I mean, you came up with catch. Okay, so then it's CH. So how do you do that? Well, maybe then you start accumulating a list of endings that require an ES, CH, SH, maybe I can't think of others right now, SS. So, then you have, if the last two is a member of this list of possibilities. So then we have things like house, you just added S. What about mouse? Now you can't just say if the ending is OUSE because house needs to just be the regular normal ending, but mouse needs to be mice. And louse needs to be lice. And then there's a whole bunch of stuff where you like sheep and deer where you English is great for this because it's so messed up. You do this in Spanish, it's a lot less interesting. It's a very short program. So again, the idea here is using a language that's designed for manipulation of language. And the educational point is this idea of construction. Maybe we should talk about it.
And also the idea of debugging, because the whole process in terms of finding the exceptions is that debugging process. It's part of it's not that the program didn't work, but the word that you use, it's not going to work for every word. So it's very important it's that kind of going back through it and looking at that and figuring out how we have to adjust the program to work.
Right.
And there's so much, like you say, it's almost open-ended. There's obviously a finite amount, but in terms of like kids working on this, there's so many different places, and it brings, like they're just very, like this kind of stuff is naturally, it's like puzzles, it's like naturally really interesting to.
And related things, things like Mad Libs,
Yeah.
which kids have done on paper for a long time. That's a common program. Now, in more contemporary environments like Scratch, wouldn't do something like this. In fact, it would be quite difficult for a variety of technical reasons. But the issues still come up. For example, you've got this video game, and your character is bumping into bad guys and losing lives, and you could have it say, you have 5 lives left, you have 4 lives left, you have 1 lives left. Oops. So you need to do a correction. The misuse of the language pops out, and then you can see the rule and implement it. So that's an example of a good old-fashioned logo thing. There's a book called Exploring Language with Logo by Paulo Blikstein and Margaret Boyers that goes through hundreds of pages of this sort of stuff. And I think it's still worth taking a look at. Okay, so that's plural, partially done. And let's, Constructionism versus Constructionism.
Yeah, so how many people have heard of Constructivism? So Piaget, right? Anyone have a... So Papert worked with Piaget, and the idea was that you construct your understanding, etc. Now, Constructionism is what Papert kind of took, and that's about really making, like constructing things. And so it wasn't just about constructing your understanding or your knowledge, but Constructionism is that idea that with these tools, with all these kinds of things, he was also a big person in terms of mind swarms, like the robotics and things like that. So there's all these tools and all these kind of physical things that you could use to understand your world around you and understand your place in that world, etc. And that's where his kind of his pedagogy really stems from, is that we really don't understand things until we really kind of put ourselves through them in that sense.
Yeah, the constructivism is right out of Piaget, which is simply that we create our own knowledge. And that, was revolutionary at the time. I mean, there are other models of how we learn. There's the behaviors model, which is that we don't know what goes inside the head and we can't. And that's an old story. nobody really is taken seriously anymore because we do know what's going on inside the head. But that's one model, and then there's what Paulo Freire, who's another great education thinker from Brazil.
The banking model.
The banking model, that you make deposits of knowledge in your head that you then draw out later when you need it.
Which is actually most of schools even today.
Most
schools, that's how they work. The teacher provides the information, provides
the teacher's the bank, and he's
well,
lending
exactly.
No,
well, it's
the
not.
knowledge he has.
No, your bank, your head is the bank.
Your head is the bank. The teacher's basically
making
depositing
deposits.
knowledge. So you don't own. With Freire, it was really a big idea about owning your learning. And so when you, especially in terms of where he was in Brazil, et cetera, working with impoverished populations and people who didn't have access to education typically, you were, you went and learned from a teacher that had the knowledge and you did not. So there was a very inequity in terms of even where you existed. Whereas if you take control over your learning and you have more personal learning in terms of like what you're interested in and it's connected to that, it's not the banking model in that
But
sense.
it's also, the banking model is also that you withdraw it later.
Right,
It's like,
for a
why do I
test.
need to
Yeah.
learn long division? Well, you need it later in life, which
Right.
is totally false. But, it's,
Fractions.
it's nothing you do now, whereas the constructionist approach to education. Constructivism is the learning theory. Constructionism is the teaching approach. And the idea is that a good way to construct knowledge in your head, constructivism, is to build something in the real world. And that's something, you think of it often as robots and things like that, but it's also, it could be a song, it could be a company, it could be, anything concrete in the real world. So that's Papert's extension of the Piaget idea of constructivism. It's a way of getting at that construction of knowledge.
Did you have a question?
Isn't there like a similar concept in math where you have like Constructionism where you prove like bigger concepts using like smaller concepts and you like use those as building blocks, keep on building, and that's like a constructionist way of like approaching math?
Yeah, and that's a very important point, very interesting. The way Logo was designed is exactly to facilitate that. There are two ways of looking at that. We did this as a top-down. We said the program is plural, and now we get all the subparts. That's a top-down approach, which is a lot of the ideology of computer programming. That's how you program. But there's also the bottom-up, which is you just start with something and you grow it. So you start with one idea, which is one little procedure, and then you expand it. So how do you make a video game? Well, some kids will sit down and plan it out on a storyboard, beginning to end. We have 18 levels and this and this. Someone else will just put an object on the screen, make it move, and say, okay, that's the good guy, and now I need a bad guy. Let me find a bad guy. Put another object on the screen. Okay, now what happens when they bang together? Okay, now maybe I need a background. And the whole thing emerges on the fly. And so, this is the planners on the one hand versus the tinkerers.
Or the bricoleurs. We have that quote right there.
Bricoleur is a tinkerer, a French tinkerer.
Yeah.
So the idea of designing a programming learning environment is to be able to facilitate both styles. And if you look at programming languages, many of them are designed for that top-down approach. You have to specify data types and all this stuff ahead of time. Whereas Logo, now Scratch, all of these, you can just jump in and do it. And what you're saying about mathematics, that's exactly right. You can begin with the pieces and then construct a larger complex from those little pieces. But in any case, what you're doing is you're getting complexity by having subparts, and that's standard throughout, whether you start at the top or start with the subparts.
So Instructionism is obviously that idea that you are the teacher or is giving the information to, directly sort of top down in a sense. And probably, you know, most of schools still tend to go in that mode at one point. You know, people believe that there's a lot of content that people need to know, and you have to give them the content. Once they know the content, then they can move on and do stuff with the content. Whereas the other ways are really that you're understanding the content and you're developing your understanding, and things come out of the making, and that you don't have necessarily the understanding before you even start.
Right.
And that understanding is developed, and there's a reflection. And it doesn't, you know, there's a lot of people that think, well, it's like a free form, or you just let people like go for it. There's been a number of, there's one very great article about messing around with science, and there's another one that is messing about with time. And it talks about the fact that it's not just about giving, you need to give kids or students, whatever, a lot of time to do things because they need time to develop their understanding, but it's not just unstructured, and it's not as if like you're just saying, oh, just give you a bunch of the stuff and then you will construct your understanding of all these complex concepts. Of course not, but that it's guided, there's reflection and things like that. But the best way for anybody, it doesn't matter how old you are, is to really be going through the motions in a sense, and not just being told what they are without any time to really work with that.
I believe that I read this in my stories, and I'm almost sure that it's a Papert thing to say. But I think one of the things that he talks about is that computers are infinitely patient in a way that human teachers can't be. And so they create a really ideal learning environment.
Yeah.
Children can keep trying until they get it.
Yeah, and another thing about computers is kind of, another part of that is that powerful ideas thing where, you know, if you can make something, then you can make something infinitely more complex and interesting and powerful when you use a computer, because that's why we created computers in the first place, right, as adults, is to help us with something. I mean,
do things we can't.
Right, and so, and use that, and so why, you know, especially in schools, we often see, there was someone at the last SEP PD that we had that was so awesome. He was talking about when he was in 6th grade, and he's like inventor of all this cool stuff, whatever, and in 6th grade, how he had hated school, didn't do anything, but he created a calculator and wrote a program for like a little calculator. They wouldn't let him use it on his math tests, even though he wrote all the functions and the, you know, so that's just kind of the absurdity of it, you know. It's like, then he was like, forget it, then I'm not doing anything, you know. But that's that idea where, you know, you're using this computer, this tool to do that silly stuff, so you can go on and do some more powerful stuff.
Anyone else have any comments or questions before we just keep barreling it?
Yeah, we can open up to a lot of,
Yeah, we're being very instructive.
Yeah.
I was wondering, learning a language, has someone done something with something like Duolingo or something like that with Logo?
Well,
Repeat the comment.
So the question was, has somebody done something with learning language and Duolingo?
well, there's a couple of issues there. One is, you know, you look at Logo like we were doing with plural, or certainly within Scratch, and it's English-like, but it's not English. I mean, the grammar is very different. So if you...
Grammar rules and syntax.
The grammar rules and syntax of Logo are not English. They're Logo. Okay, some of the words, and you can when you create words, you can create them as familiar words. So there's a limit when you know, it is language familiar, but now, having said that, Scratch in particular is set up, it's implemented in like 40 different languages, and you can toggle from one to the other on the fly. So if I write a program in English, Scratch, share it, you go get it in whatever language you know, you don't know English, let's say, you just click. We're off
I'm
the,
already there.
She's showing the
I'm actually
languages.
showing that you can actually change.
oh, you're in,
from,
okay.
I'm in
French,
projects. Yeah. So I'm going to actually, let me get it. Let's
Now,
change
you
it.
won't change the text that Kelly wrote. It
Yeah,
changes
changes the-
blocks.
And it's actually pretty neat. I've used it in my classroom when kids, it's like an equalizer because kids can choose whatever language they want. I had one kid a couple of years ago that had just arrived, in the middle of the year from Korea, I think, and she was able to just go right into my Scratch unit, which I happened to be doing at the time, and be on equal footing with everyone else, and probably having a really
But that's not what
successful
you're-
time. But that's not what
That's not what you're talking about.
What I'm asking is for a language that is not in computer, is not translated into computer language. How easy would it be for you to build the language and syntax and grammar structure of that language if it is not already computer?
Wait, are you asking how easy it is to implement
There was
this?
syntax rules, the rules of the language.
So you're not asking, like,
How to translate, no, I'm not asking how to translate.
you just want to create a new language?
Yes, I mean.
So you were thinking like if we did that plural thing, but you did it in Spanish instead?
Well, my interest is now, because
Okay,
now,
yeah.
and now if it was not something
Oh,
that
right,
is
yeah.
in any
Right.
kind of
Yeah.
computerized format, what you have to do is you have to, and it's like English, it's very unwieldy. So you have to take all of these rules that you have for being able to create words in an alphabet, and to be able to, because now it is still spoken because it's, you conduct
Okay,
business in it.
so if you could do this plural program. Okay, the alphabet is Roman alphabet, right?
Yes.
Yes, but,
it's-
okay. All right, doesn't matter. That part is easy. You can see this can be done in any
Right.
alphabet. Okay, so if you did, say, a plural program, your program would be very different because it's not English, but you could do the same thing.
That's what I'm asking.
Yeah, of course.
Yeah.
As I said,
Because you would just use different rules.
if you're doing this like in Spanish, it becomes a lot simpler. Other languages, it depends.
Depends on the
Okay.
rules, the exceptions, actually the exceptions to the rules as
well,
well.
or
Depends on-
different, like in Malay, you just repeat the word. If you say, to get people, you say person, so that's a whole other program. But yes, you could write that program.
Uh-huh.
Well, do you think that Scratch is losing something that Logo had in terms of language versus? Earlier you said something about Scratch.
Yes.
Is there a way to use Scratch to recapture?
Well,
is there a way to recapture some
something
of
like
that
this
in-
plural program would be extremely difficult to do
Right.
in Scratch. For some technical reasons, like the idea of output,
Yeah.
you can't create a procedure in Scratch that outputs. So you have a whole different structure. I think you gain a tremendous amount in Scratch, and overall, I think it has a much wider appeal than earlier versions of Logo. But I think also the more general point is text-based languages lend themselves to much bigger programs. And one of the limitations with Scratch is if you try to make a very large program, you're just running out of screen real estate. It's hard to keep track of things. So there's definitely a place for text-based languages.
So is there still then, so in our school where I've been teaching Scratch, full Scratch, and we're beginning to look at kindergarten through second grade, beginning at robots and Scratch. And then the computer lab has been teaching Mindstorms, but the teachers retired, so we were thinking about Scratch. Should we, once we're through Scratch, how do we reintroduce some of the concepts?
Well, that's an interesting
Where's the
question.
switch, and how do we not lose that?
Well, it depends. There are different directions to go, I think. This is a whole other discussion. But, what happens, you've done Scratch. Now, for some kids, they're just going to do Scratch for years, and it has a tremendous range of possibilities. One direction is there are certain limitations on more advanced concepts in programming. It doesn't necessarily mean going to a text-based language. It is Snap, which is an enhanced version of Scratch that allows for more in-depth computer science. Another direction is to go to mainstream programming languages, like JavaScript or whatever. And the main reason for that is people want to mesh into those cultures, and access the crowd expertise around those languages and do practical things. So that's another direction. as far as going to this text-based logo, there's not a lot left for that, I think. I mean, I think it's great.
My students love it.
Yeah.
I mean, I teach it, and I teach 6th and 7th graders and they think, I crack up, but they're like, this turtle is so amazing. Like, you know how they just are so excited about
that's
the
the
little
turtle.
When you say turtle, what do you mean?
We'll get after
because
this.
Right.
Yeah,
No,
in
but see-
micro worlds, that
All right.
you're a lot of great, like micro worlds. I think a lot too is the geometry aspect. It doesn't have to be, but logo kind of moved from when. Oh, we have the turtle pictures too. Yeah. So the turtle, we'll introduce the turtle, but the turtle becomes and Python uses a turtle. There's you can use a turtle in Python.
And so, jumping in with Tracy, you can go in either direction, logo or Python. The nice thing about Scratch to Python is if you write Scratch code and Python code and literally erase the blocks around the Scratch code, it looks almost exactly like the Python code. The syntax and structure are almost exactly alike. So it's a really nice transition from one to the other. We just did that transition with our 9th graders at AFSC a couple weeks ago, and they are drawing castles and
So if we blew away the micro worlds.
Well, it's different, but the turtle's different in Python.
Yeah.
It's with micro worlds. You're really talking about
I think it should have.
working with yourself in geometry and moving around in terms of like the space. So it gives kids like this really great access to like sort of geometry, angles, shapes, and then also procedures and iteration is really interesting with that too, because it's so visual. And so you can come up turtle art, which we were going to talk about also.
One of the groups was like,
I mean, you know what would be probably great for the age group is turtle art, right? That would be, yeah, we're going to show it, but I'm just thinking about your age group, because that works with, it's that idea of like you're constructing these like ways of creating these visuals, fractals in a sense, even but like all these iterative designs, and then understanding how those are constructed and putting these pieces together. So turtle art is something that was developed, which uses block-based programming, but kind of works with the turtle in the same way.
I mean, I think, the idea of the turtle, let me get it up there for now. Sorry, we had a chart.
So Kelly is coming around with you have your computer, or you can get your computer. Kelly is coming around with a program that you guys can load up and give it a try.
Let me say something about what we're giving out here. This, we're going to show folks, please. Everybody listen up. Please listen up. Tracy. On these flash drives, there's program turtle art. There's a Mac version and a PC version. You can drag it to your desktop and then install the PC version. The Mac version, just drag into applications. This is a program that is it's not a commercial program. And the people who developed it, which is Brian Silverman and Artemis Papert, have a website that I'll point you to, which is turtleart.org. And make a note of it. And we're giving this out on the understanding that you're going to email them and tell them you've got it. Because they want to keep track of everything. This is for good reasons. They can tell you updates and things. So if you're taking a copy of this, please go to turtleart.org at some point in the next couple of days and email them and tell them that you were at this meetup and you got it. Now, having said that, I'm going to leave this up for a moment go to this, which is where the turtle comes from.
Yeah.
Now, the turtle was originally a robot, and that's Seymour Papert some time ago with this robot turtle. Now, the turtle is not logo, and logo is not the turtle. I mean, the two get conflated because most of what most people did with logo in the early 80s was using the turtle. The two are not the same. Logo is a language. It happens to be a very good language for speaking to turtles. And, you know, as you were saying a moment ago, there's turtle graphics in Python, so you can have a turtle without logo,
Exactly.
and a logo without turtle. Having said that, the first version of logo, the computer had no screen. So
Came out on a
it was
teletype.
a teletype. And the first version had no turtle, no robot, no nothing. But fairly soon they started creating these robots. And the idea is that it has two motors. And if you roll both motors forward in the same direction, the turtle moves like that, or like this. Now to turn it, if you move them in opposite directions, it does this or this. End of story. So it's an incredibly simple structure that you wire to a computer, and there are 4 commands. There's forward, back, left, and right. And with that, you can move that turtle anywhere in the room. And actually, of those 4 commands, you only need 2 of them. Think about that. There was a little more to the story. There was a pen.
Yeah.
And the pen can be penned down on the floor, in which case it draws when it moves. Or pen up. Now here is something that turtle drew. Now there's some part where the pen was up, like to get from here to here, you had to move into that center without drawing. Or maybe again, this is that issue of bottom up and top down. They draw the outside fish first and then these parts, or did they do the eye and the gills first? Don't know. You only know that if you saw the process. Okay, so that's the floor turtle, and there are a few others. That's another view of it. Here's some more. And you see the designs they're drawing. That's a close-up of the pen of one of these turtles. The white curvy thing is just a tail. For balance. It rests on it. And this actually was done at the Lotus Summer Institute last summer. Somebody created a turtle out of Lego NXT.
That's the interesting thing about everything if you read from Papert, like even like a lot of these quotes, but if you read his stuff, you could swear it was last week that you just saw that, you know, on Facebook
Right.
somewhere or wherever, on Twitter or,
So here
you know, it's all,
a few more.
he already said it. He already critiqued it.
So some rather elaborate patterns, and we'll get to these in just a moment. Okay, so that's an introduction to the turtle. Now the important thing to remember there is that when
I just wanted to say,
I'm sorry.
I just wanted to comment on something Tracy just said, which is that it's not just that Papert was kind of influenced things which turned out to come true. It's that he actually, like Lego Mindstorms, came straight out of his lab.
Yeah.
Just so that there's this amazing bifurcation both on the programming side and on the robotics side. And so much of what now passes for good practice in sort of K through 12 education in this area, it's not just that there's some vague lineage, it's very direct, very
Yeah, it's very
explicit.
direct. And
lineage
Lego is a
from
major
what he
funder.
and his colleagues were doing.
It's a major funder of the Media Lab. and that's-
The reason it's called Lego Mindstorms is that they licensed the name from it.
Right.
Yeah.
No,
And
that's true.
a lot of, that's the thing too, that's always interesting about Papert, it's so much about, so many things that we don't realize we reference are his. But also just the idea of like, well, I'll go out on a limb and say like, you know, school basically sucks. You know, he understood that the institution of school, like, you know, if you weren't going to change the, you know, you can't just change the concepts, you have to change the the way the concepts are presented if you're going to get any kind of changes. And so, just that, when you think of school reform, education reform, and all kind of conversation, like it's like.
But also, I do feel like I'm not sure. I would have loved to have been able to talk to him about this, because it's not like he's the guy who first decided or articulated the school such. I mean, we've had progressive education for 100 years, and I always wonder, like, is the only experience Papert had of school big institutional public, corporatized education?
No.
Or did he ever visit
Yes.
a progressive school like Bank Street, Country, Little Red?
But,
No.
okay, now here's the question. I mean, yes, but, and this has been my concern. I've been actually thinking about this a lot more recently when I just visited a former student of mine, when I was teaching elementary school, and she's now the headmistress of a progressive school.
Wow.
And, she says that a lot of what she has done as a teacher now as a head.
What's school?
High Meadow, Stone Ridge, New York. And, that she got from me when she was in my class, which I took as a great compliment, because she's got a great school. But what I'm asking her now is, what are you doing with computers? And the answer is not a whole lot. And so I'm looking at this now. You had progressive educators who, in the early 80s, I mean, that's where I came from. When I signed on to this logo world with Papert, because that was natural for me. I mean, coming out of a progressive education background, I mean, I was at the Workshop Center for Open Education at City College. Has anybody heard of that? Lillian Weber? Ancient history, but this was progressive education, fully flourished. And progressive educators, for the most part, did not adopt logo or computers at all. So why? That always has mystified them. And that's a long discussion. But at the same time, and probably this is one of the reasons, the answer to the first question, many people who use logo were using it in very instructionist ways. So you have this dual thing.
Have that
Well,
problem now too.
Scratch is having the same problem. So you have, on the one hand, progressive educators look at this stuff and say, not for me, and instructionist educators pick up what was designed for constructionist purposes and use it in different ways. That's a whole other discussion. Because we don't have that much time. Let me get to Turtle. The important thing, why I showed, we always show, before using Turtle art, those images of the floor turtle. If you get a floor turtle, even better. To understand how this works, picture this turtle that was on the floor. And now take the floor and lift it up. So now you're looking down on the floor. And that's the back of the turtle. So, now how does this work? Well, now this, again, this is a blocks programming environment. This is turtle geometry and turtles with logo are very old. This is a recent program.
You drag down the window.
Sorry?
Drag the window down just a little, center of the window. Yeah.
Okay. Is that it?
Yeah.
Okay. So you just drag things out. So this forward, and it automatically sticks a number in. You can change that number, but I'll leave it alone. If I click on it, double click, turtle moves forward, and the pen is by default down. I can pick it up. Now I'll take out a right 90. Okay. Now I can put these together. Let me click clean it off. And now if I click the stack, it does both. I click it again. What have I got? A square. So moving along very quickly here, I can make a new block. Go back here. Low. So how many times did we repeat that? 4. So I'll change the 10 to the 4. I'll double click on that. Let me clean it again. Okay. Now, I want to give this a name.
Yeah. No,
I'm going to call this square. So now, I've automatically created one block called square. So if I do clean, now I put the square. So what if I do this? Square and right 45. Create square, no square. Okay.
But people can go home and try this.
Yeah.
And actually, as an inspiration, if you go to the Turtle Art
Yeah.
website, Ryan and Artemis have made the most, I mean, some of the work that they have done is amazing.
And the really cool
Totally
thing,
amazing.
the really cool thing about the art that they've done is every single piece you can actually download it. If you open it up in Turtle Art,
Yeah, you
the
see the
file you
code.
can actually see what the code
Yeah,
is.
watch this. This is magic.
Check it out.
Yeah, I'm going to take, how's this one? Good? Drag the image from the website onto the Turtle Art application.
And da-da-da.
Patience, patience.
It's complex.
Yeah.
I'm not sure it got dragged.
Yeah, I don't think it drags.
It did drag.
It
but
did, but
it tried to-
might take a while.
It was an image that it tried to load. It's not the code.
Or
No,
it's
it
No,
is
but
the
the
code.
code, the image and the code are
it
one.
takes a.
That's what's so
it-
cool. Like
it's
you say the
actually in
PNG, and it has the code in it. Yeah.
It's embedded, the
Yeah.
code is a PNG.
Oh, that's
The
okay.
code is
Right.
embedded in the PNG.
I think maybe.
But
if you
look
open
at
up-
all, like, I mean, really amazing stuff. Like beautiful, beautiful art. Yes. Yes, that's what we're going to show. But if you go there,
But it should,
there's the.
see now,
But behind this, behind the blocks,
Yes.
I mean, is it possible?
Well, that's the code.
that is the
Blocks are
code.
Okay.
Yeah, so
Yeah.
it's not like text-based. It's
If you want to just look at the image, you can hide the blocks and show them. Now, for the technically minded, what Brian has done is he's grabbed a couple of bits out of each piece of the PNG and stuck the code in there. So if you use that PNG file, if you save from Turtle Art, you're saving what looks like a plain PNG, but it's got this
Yeah.
hidden component. If you use that PNG in any other application that takes a PNG, it's a plain old PNG. Its color depth is slightly
Yeah.
reduced because he
It's a
grabs
two.
some bits.
Yeah.
But that's it. So I encourage you to play. We don't have much time, but it's a
But
great
it's
little
awesome,
program.
and for younger kids, I mean, it's for any kids. Obviously, you can see the quality. I mean, very, very complex and very amazing stuff. Brian's very interested in the art aspect of this.
And Artemis is the artist, so
Yeah.
she's been doing all this good
Yeah.
stuff. Yeah.
So I learned how to program using Logo as well, actually. But when you were going through the examples, it just sort of like you click the button and then the turtle moved, but you didn't actually see the turtle move.
Because
So,
it's so
like,
fast.
Yeah, so
You can
like,
slow it down.
you can like slow it down, right? Like, you
Yeah,
should-
by quick wait.
Yeah, you can.
But that's a really awesome way. Like I always say to the kids, well, what can we use?
So like I mean like for the visualization, just
Yeah.
see, like it's
Oh,
not
I
just
see
like
what you're
from
saying,
beginning
yeah.
to end. It's just like sort of intermediate.
You're absolutely
stuff.
right.
Yeah.
And I was jumping too fast because
Yeah, that's true.
You definitely should do it step by step.
Okay.
Yeah.
And in fact, starting without the pen down. So you can get the turtle to move in a square, but it moves so fast, all you see
You
is
don't- yeah.
the
You don't
turtle
see
back
it.
exactly
You
where
won't see
it
it.
started.
Yeah.
And then you introduce the pen.
Yeah,
and then
I mean, there's a whole
So
way, like
different.
when I teach it, I love it, because, I mean, even more than Scratch, I mean, the kids love Scratch, but there's something magical, and I don't know, they love that turtle, boy.
Yeah, I think this is great. But, okay, so we're out of time. A couple of things. Remember, if you've got this program, enjoy it, and please email them and tell them you got it and you got it here. If you want to really dive deep into all these things and much more, Logo Summer Institute coming up in June. There are flyers on the table there. And the next meetup, we have a Scratch meetup on the 7th.
May 17th. On Saturday, May 17th, there's a Scratch Educators Meetup. Some of us are trying to actually have a big hackathon. So if you're interested, come. I want to thank everybody for coming out and helping us nerd out on
And
Seymour
there's a lot of
Papert.
resources for Papert. There's papert.org, but then there's also Gary. We can give Gary shout outs. The Daily Papert is, no, seriously, it's like,
It's amazing.
I mean, because there's so many amazing things that he wrote, and if you read them, you're saying, wow, like, yeah, it's.
And I included a bunch of those links in the Scratch project that was tweeted out earlier. So Daily Papert, a really fantastic talk on Papert, some other fantastic, wonderful things. Seymour Papert, super
And if you
awesome.
read Mindstorms again, or if you're reading it for the first time, remember the forward, the last passage. The middle's good too, but
I just had to read it for my learn, which was always like a nice little reason to have to read it for the 8th time. Or
at
whatever.
least, yeah. Okay.
Can we give it up for our presenters?